Alright, so today my plan is to melt down a little bit of aluminum and experiment with pouring it into my mold at a temperature, keep warm to the mold, and make the aluminum as cool as I can to have the least differential in temperature to see if that leads to a higher quality cast. So I left the furnace sitting out here in the rain, so unfortunately I had the lid on, but there's a hole in the top of the lid, and so some moisture got down into the crucible. So I've got the fire set at a pretty low flow. You can kind of hear it sort of sputtering, and I'm just slowly heating the crucible up. I may not be able to see that here. I wonder if I can zoom in. You can see yep, there it is. You can see a little bit of the water vapor that's turning to gas and making its way out of the crucible. So as long as that happens slowly enough, it's not going to create any explosions and crack the crucible or break it up. So not super worried about it, because if it did explode, most of it would be caught in the furnace. So I am wearing, of course, my face guard, and so protecting my eyes is the key thing. So let's check the temperature again here. So it's bouncing around between 160 and 190. And of course, that's picking up heat off that aluminum that's just in the very top of the crucible. And so there's probably much closer to 212 down in the crucible. And I'm seeing less steam coming up out of that. So we may be getting close, but there's enough that I'm hesitant to crank the heat up. I may just turn the crucible a bit to kind of bake the other side. Didn't crack when I was doing that, so that's a good sign. So it's always kind of a challenge, because the furnace is quite hot. It's not the outside, but the inside is quite hot when I'm done. And I don't really like carrying a very hot object and setting it somewhere where there's combustibles nearby, so I leave it here, and then when the rain comes in, you get rainwater washing the outside of the crucible, or sorry, the furnace. It looks like I got a few little rust stains on the ceramic insulation. So yeah, one way or the other. See what we got here. That's getting there, about 180 or so. Let me see if I can pause this without stopping it. Well, it has taken a surprisingly long amount of time to get this thing warmed up. I think all the moisture probably that kind of soaked into the probably just from the wet, damp air that soaked into the ceramic insulation. All of that steaming off absorbs a great deal of heat. So in fact, the top part is still steaming off. Here, I'll show you. Hopefully you can see the kind of clouds of steam coming off. Not as much as before. The crucible normally would be red hot by this time, but it's running only 1100 degrees or so. And, yeah, but this time it should be 1500 degrees. So, but it is getting hot enough that it should start melting that aluminum shortly. So I think I may start filling it with some scrap I've got here. It's always kind of fun to put tinfoil things that were, I don't even call them tin, they're actually aluminum, that were used for food, because as they heat up, all that food stuff burns, and you get this lovely, like, you know, apple pie smell or whatever it is. And it's almost like you're cooking, but of course you're not. And there's not enough of it there to really give it a burn smell. So it's kind of a nicer smell to have. So another fun one is when you melt down the little cans of cat food. I've got one of those right here. There. Some of these are made out of steel, but then other brands, this brand is made out of aluminum. If I can show you. Friskies. Anyway, when that burns, there's a little residue of the fish in there that the cat didn't quite get to. And so it has this, burning, cooking meat smell very briefly as that melts down. So that's kind of fun, but I figured I wouldn't mix the pie smell with the fish smell. It seemed as appetizing. And, kind of fun to have them in sequence. Yeah, it's interesting. The outside of that little aluminum pie shell, it was right at the point of melting from the heat in the outside, but the inside of the crucible is still cooler than melting temperature. It hasn't heated up quite yet. So, material down inside, the Oh, that's interesting. I got something on the stirring spoon here that's burning and sending up a whisk of smoke. Yeah, the inside just does not want to heat up. It's just taking a while. I may pause it so you all don't have to sit here and watch nothing happen. Alright, so it's heated up a little bit. I went ahead and stuck the little cat dish in there. Send up some nice fire from the paper burning off. Toss a little more scrap in there. Missed on a couple pieces there. There'll be a little aluminum in the bottom. Done. That's probably enough for now. So we're waiting that to melt down. Thought maybe I'd show you a little bit of the scrap container I've got here. So bent pieces here. This was for the top of a pour, went down to the sand, so it flowed through there to what I was casting underneath. So melt that down, redo it. This is some extra aluminum I had, and I just poured it out on the ground. So that's the bottom that was against the ground. So I poured, I think, up there at the narrow end, and it flowed down to a dip and came to a stop. I didn't have anywhere else to pour it. This is another piece that dropped into a little pit that I dug in the dirt here. There's another piece that went a little pit in the dirt. So not exactly a grand cast when you do that, but it saves off your aluminum, and then you toss them in the bucket and melt them down again later. I'll zoom in here a little bit. See what's going on in there. Not really much. It's melting really slow. Might be fun to watch that little can melt down. It may end up spilling over the side. surviving for a remarkably long time. Tempted to see what will happen to it. I'm sure it is quite weak by now. It seems to be collapsing a little bit. They lose structural strength quite a bit before they actually melt. Yeah, just sort of just hanging there. Barely tap it, just collapses. Now there's a little bit of molten aluminum in the bottom here. Stir it around a little bit there to get the heat evened out. I really want to do this pour right away. Starting to feel the warmth in my gloves. Don't want to give them too much warmth here. The leather here on the fingertips, if it gets hot, it starts to harden. And I prefer that not happen to these gloves. I wasn't real careful early on, and so I started seeing that happen, and I'm like, what's happening to my gloves? I think it's ready to pour, but I can't see well with the fire, so I'm going to shut it off. Alright, so let's see. There is some dross in there. The material I put in was clean, but there was some dross in here already. And I put in some stuff that was aluminum that I pulled out of the dross, so it contained a fairly high dross quantity. Almost looks like it was mostly dross. There. Okay, I'm about ready to pull this out. All right, I'm kind of taking my time this time because I want to reduce my temperature differential. Experiment there, set the lid on, put the mold over the top. I think I'll just leave it there for like a minute or two. Kind of let it absorb some of the heat. And let's grab the temp sensor and check that out. And it's not as hot as I was hoping. It's picked up to about 80 degrees or so, which is better than what it would be sitting out here, which would be probably about 40. But still, from a differential of 1300 degrees to 80, that's a pretty big jump. Now it's up to about 120, but I do not want my aluminum hardening down there. So I think I'm going to go ahead and pour. And, let's see, I'm going to zoom out a bit so you guys can see that process happen. All right, that's step one. So normally pouring into an ingot mold, I would want to take the spoon and whack it as soon as I got it in there to kind of flatten the top. But I've got some quarters in the bottom that I want it to kind of capture the images off of it. And if I do that, I'm thinking it may damage that. So I'm just going to pour it in, see how it turns out. Emptied out the crucible there and caught a couple leaves on fire, and then more of that's probably steam, moisture in the ground just coming up. Not wet enough to be a danger, thankfully. So it looks like the bottom, it's got a lot of dross in it. Let's see if I can scoop it out while it's kind of hot. So, I have a pretty red color. Alright. Well, it'll take a while for the crucible take a while for the crucible to cool off, so just gonna stick it back here in the furnace. Toss the lid back on, and well, let's I'm gonna pause this so you can later see how the ingot turned out. All right, so I brought the ingot in here with my mail. Of course, I was wondering if I slid my mail into the ingot, would the mail catch fire? Of course, that's obviously something I have to try, right? Nope. Although, almost looked like it might have be turning that a little bit dark, but not hot enough to catch mail fire, so that's kind of nice. So let's pull the ingot out of the mold. There's our quarters there in the bottom. And let's see if it's above 212. I'm going to bet it is. Let's see how this looks here. Oh yeah, that's the part that was on the ground, and it was definitely above 212. Oh yeah, there we go. Always fun how it kind of bubbles. It creates the bubbles underneath the ingot and bounces it. So, anyway, let's, now that we got it cooled off, let's see what it looks like. Well, that's going to go back in that scrap bucket. Let's see how so, yeah, it kind of bubbled on that one a bit. So you don't really have a nice shape that went in there. I wonder if I can zoom in here. My hands are wet. My phone doesn't want to react to wet hands. But yeah, you really can't see the shape on that one. These others are affixed more. Let's see if I can pry them up. They may have left a better shape there. Unfortunately, not really. Aluminum just kind of sat there. I don't know if it's heat differential or what that makes it not. So these last two are less happy to come to break their way out. So I'm going to work on them a bit, pause this, and show you the results. Okay, so here we go. So it's interesting that for whatever reason, when the aluminum hit the penny, so I poured from the top, and I don't, let's see which end, it would have been this other end. So I was pouring from this end. And so as that aluminum here went down in, it hit the coin instead of forming a nice surface. I mean, there is some spots there you can kind of see some of the writing around the edge of the coin, so it affixed, but it created this kind of bubbly characteristic to it, which is rather, you can see a little bit of text right up there, but for the most part it just kind of bubbled and didn't make a very clean adhesive surface to the quarter. And then here's the next one, and this one again, very bubbled. You really can't see much of an image there. Again, this one, not much of an image. And this one, not much of an image. Probably our best bet actually is this one, because if you kind of zoom out, you get a little sense of something that used to be here, and there's some text there that is somewhat visible. Though as you zoom in, you just it just doesn't really, yeah, it's not a good copy of the quarter. And so I'm really not sure why. Maybe it's the metals in the surface of the quarter is interacting with the metal here, because the graphite surface here, although it's perfectly smooth, it seems to affix itself quite cleanly to that surface, although it does problems getting into the corners. So it could just simply be that the surface tension on the aluminum is preventing it from making a particularly fine molding surface. So I've noticed as a general rule with aluminum, it seems you need to overstate the shapes that you're wanting to make so that the aluminum can kind of flow into those. So anyway, the bar itself, other than the bottom, which is kind of like, yeah, what's that? The top, so this is as it cools, it shrinks and compresses down into the middle. And right here is where I pour. You can see a little bit of a disturbance there on the surface. But otherwise, it's got kind of a fun, smooth, shiny surface. You know, it's like kind of something rather solid. So, kind of a fun experiment. Hope you all enjoyed watching.